Hello, my dear students. In this video, I'll be discussing about DC circuits, particularly the concept of electric current. Okay, so let me share my video first. Okay. So we are now already, at this point in time, we have reached our study of, uh, what is this? Ayan. Reach our study of direct current or DC circuits. So let's just have a very simplified differentiation between direct current and alternating current. So from the symbols of the voltage sources, you can immediately see that for the direct current, we have here a very good example of um, a voltage source as a battery, okay? And then this one, on the alternating current, you have the symbol for a sine wave, no? Uh, which indicates the sinusoidal behavior of the voltage, no? And this is supplied by an AC generator. But that will be another kind of study. So if you notice, the dots here represent the moving charges. If the pathway for the charges here were metal, no, a metal, then these charge carriers are electrons. So if we consider this to be conductors, itong dalawang wires natin dito, then we see here that for a direct current, you notice that the electrons are just moving unidirectionally. Okay? Uh, wait, it goes out from the positive and enters the negative. This is what we call conventional current. Okay, I will discuss it in a while. So again, these are not electrons, but these are this is a conventional current, which is composed of a positive charge carriers. So if you look at the charges here, they're moving in one direction only. That's for direct current. However, in the alternating current, the electrons need not go around the circuit or around the loop, but they just oscillate. Okay, so there's an oscillation. That is why the outlets that we have at home, no, yung dalawang saksakan yan, you cannot identify which is the positive, which is the negative, because the polarities of the terminal of the AC source changes sinusoidally. So meron siyang frequency. Kaya if you notice, sa chargers, for example, it's usually the frequency there is always denoted, no? So for example, 60 hertz. So the hertz there is telling us that yung AC voltage natin na saksakan or outlet, the polarity changes 60 cycles or 60 times per second. Okay? Kaya sinusoidal siya. I really hope that you can learn more about alternating current now, but looking at the time that we have now in this semester, I doubt that we can reach a discussion on alternating current. But anyway, let's just maximize whatever we have here. So in other words, in our study of DC circuits, we only be dealing with voltage sources like power supplies, batteries, hindi yung AC na outlet na meron tayo sa bahay. Okay? So that's one direction only. Now, the next question would be, uh, why can metals conduct electricity? Or in other words, what's the main difference between a conductor and an insulator? Okay, so you might probably answer conductors conduct electricity, of course, and then insulators do not. But if you dig deeper into the subatomic level, the the main difference in the characteristics of a conductor and insulator lies on the presence of free electrons. Okay, so you have here a picture of, let's say, a metal crystal lattice, wherein the positive circles here are let's say the ions, no, or let's say the the positive nucleus, and then The small dots here are what we call free electrons. So you've probably learned this in your chemistry, no? Free electrons, these are valence electrons, the outermost electrons, or the electrons at the farthest energy level of the atom. And since they are farthest from the nucleus, these free electrons are really free to roam around the metal, no? It can jump from one atom to the other. Okay, so this presence of free electrons, uh, this gives the characteristic of conductors to be able to allow electricity to pass through it. Okay, for insulators, they do not have this free electrons, so all their electrons are not free to roam around in the matter itself. Ayan. So that's the difference now. So however, okay, let's look at the animated GIF here. These are, ayan. Okay, so again, the red small dots are the free electrons. Yan. So if you notice in the initial part of the animation, there's no common movement. But then when the green arrow appears, there's a common drift na yun, among the molecules. This part, there's no external field yet. So it's just like a wire that is not being connected to a closed circuit. And then in this part now, wherein you see the green arrows are actually the direction of the electric field. So since the direction of the electric field is going to the left, then the negative charges, the electrons, will move to the right. So this common drift motion of the electrons now, that is now what we call current. So if we determine how many electrons passes through this area of wire per time, then that's not the definition of current. Okay, so in other words, if you have a wire, for example, like this wire in my earphone, if this wire is not yet placed in a complete closed circuit, the free electrons inside the copper wire, no, the outside is insulator so that I will not get electrocuted, right? Pag sinaksak na natin. So there's copper wire inside. And then copper wire is one of the best conductors that is also very much readily available sa atin. So, ibig sabihin, si copper wire, it has tremendously high number of free electrons per volume of a copper wire. No, I'll show you the values later. So with the number of free electrons per volume of your metal, this number of electrons, they have different directions, no, like this. They just go in random directions from one atom to the other. In that way, if there's no common drift velocity like this that you're looking at right now, then the wire, there's no established current in the wire. So there has to be an established external electric field that will somehow command the charges to move as one. And this motion as one, and then we get the rate, no? How many charges move in your wire, okay, per time, then that is now current. So, ayan siya. I hope you got that. So that's the difference between a conductor that is not placed in a closed circuit yet. Okay, the free electrons are never at rest. They just move from one atom to the other in random directions. But once your wire is already connected to a circuit where there's established electric field, then that's the time na magkakaroon ng current or electricity doon dumadaan sa wire mo. Okay, so that's the idea. Okay, so we will quantify and determine the factors that affect the amount of current that passes through our wire, no? Focusing on DC circuits only. Ayan. I'll make another video discussing resistance and electromotive force. So for this video, just focus on current. Okay? Ayan. So another animation. Therefore, we say that if we're talking about circuits which have high or large current, then you imagine that there are many charges passing per time in the wire. No? So this is a very simplified animation for that, no, for large current circuits. And then the violet ones here, you notice there are fewer purple circles. So these are the charges, the charge carriers that move in the wire. This is for small current, few charges per time. So you have charge per time, so that would be uh, the unit would be coulomb per second, which is more commonly known as ampere. And then the capital letter I here is our symbol for current, I for intensity. Okay. So, ayan. Let me go to another. So, let's try to quantify this time or determine the factors that affect current. Ayan. Let me share this one with you. Ayan. Okay. So, let's talk about current. Simply said, you can find this in any physics book, no? Or you can just see this in the PowerPoint that I have uploaded in our Moodle. So the basic definition of current would be the rate of charge, no? Moving, so there has to be motion. So we are done with our study of electrostatics, wherein the charges are not moving. This time we are now into electricity because the charges are already moving. No? So current is just the rate of charge moving, rate na nga, no? So we can say uh, amount of charge, charge moving per time. Ayan. So that if we have, for example, let's say we have a circuit diagram. So I hope that you memorize the schematic symbols of the common circuit elements, no? So that when you're given a circuit diagram, you immediately know what the symbols mean. So this is our symbol for voltage source or battery, for example, or power supply. And then the longer line is the positive terminal, the higher potential. And then the shorter one is the negative potential. So that's say that's the voltage here. And then let's say we have our resistor. So this is our symbol for resistor. So we have a very simple circuit here. No? It's just composed of a single resistance R. Okay, ayan. So if we zoom in, let's say this part of your wire, and then i-zoom in natin siya. So let's say this is the wire now. Okay, whoops. Angit. Sorry. There. So this is the segment of the wire that I have here identified here. Okay. So say for example we use conventional current. Conventional current. So for conventional current, which we will always use in our study of electricity here, the charge carriers are positive charges. Okay. So this will have the same magnitude as a charge of an electron. So we say that the charge of these positive charges would be positive 1.60 times 10 to negative 19 coulombs. Ayan. And then the motion of the positive charges would be, since it's positive, it gets repelled by the positive terminal of the battery. So parang you can think it that way para hindi kayo malito. So it comes out from the positive being repelled by it. Ayan. So this is our positive charges, conventional current I. Ayan. So it goes, so ang motion niya goes, ano na lang, we say that the motion is from positive terminal of your source, from plus to the minus. So in this case, the conventional current here, since we put the positive terminal on the left side, then the conventional current goes counterclockwise, yung current natin. But the other one is called electron flow. Electron flow. Yan. So, see electron flow, obviously, the moving charges are electrons. So, we know that the charge of an electron is negative 1.6. So same sila ng charge sa conventional current natin, negative 19 coulombs. However, the motion is opposite. So it goes away from the negative of the supply and then going towards positive. So repelled by the plus and then attracted by the minus. So the electron flow this time would be, in this particular case here, it goes clockwise yung electron flow natin. Yan. For our study of the remaining parts of the chapters, we will be using conventional current. Okay? So, ayan. So much for that. So for the conventional current here, we say that the drift velocity is going, so the direction of the current, conventional current here is from left to right. So we'd say that this would be the positive charges moving. They are still jiggling in their place, but meron silang parang common na drift velocity. Okay? So we'd say that the drift velocity is going here. Drift velocity again is the how do I call it? The common motion of the electron. So they can still jiggle in random direction, but as one, they move as one. And this drift velocity is very slow. No? Ayan siya. Yung mass movement nila is very slow. Ayan. So if they go here, so we say that if we identify this if the cross-section area is called A, and then we have here electron density N. So, pag sinabi nating electron density, it's the amount of free electrons per cubic meter of volume of conductor. So, N therefore is number of electrons per volume. Yan. So, let's stop for a while and let's show the electron density of some common metals. Where is that? I think it's somewhere here. Okay, wait. There. Okay. So, ayan. Okay, so the electron current is the number of electrons passing through this cross-section of wire per second. Yan. So every metal has its own number of free electrons per cubic meter of volume. So if you look at the table here sa baba, you have aluminum. So for aluminum, if you have a volume of 1 cubic meter of solid aluminum, then you'll be able to have 6 times 28 zeros number of electrons per cubic meter. Okay, so that's what we mean by that. So if you look further in the table, you see here that copper, okay, copper and iron actually has the greatest, no, among the 5 metals that are shown here. Si copper and si iron has the greatest value of electron density. So if you have common volumes of copper and aluminum, you'll have more free electrons present in copper than in aluminum. So the more free electrons per volume, the greater the electron density, the more charge carriers are present to actually carry energy in the circuit. Okay, so parang ganon. So in other words, mas copper is a better conductor than aluminum. So ayan siya. That's what we mean by electron density. So that the unit here is 1 per cubic meter. So that's for N. Let's go back to this one. Ayan. So if we have that density, okay, and then if we take, for example, a very small or short distance, no, infinitesimally short distance, ito for example, yan, wherein this small distance traveled by the electrons, let's call it dx, and they travel at this speed vd. Tama ba? And then meron kang ganyan na tawag nito, concentration of electrons. And then each charge here carries Q. So we say therefore that uh, if we want to get dq, for example, okay, capital Q here would be the total charge, no? Or sometimes we use capital Q if the charge is constant, meaning it doesn't change with time. So so the amount of charges that passes through this small volume can be, okay, it depends on the amount of charge that is present in the wire. And then of course, what is the electron density of your material? So copper ba yan? Aluminum ba yan? It has a certain value of the N. Okay? And then we multiply it with the volume here. So the volume is just given by the area of the circle, cross-section area of the pipe, of the wire, I mean, times the short distance here. So area times length, this will actually give us volume, isn't it? So if we look at the units, let's check the unit. We have charge is coulomb, and then electron density is 1 per cubic meter. Area is meter per second, and then distance is meter. I'm sorry. Tama ba? Sorry, mali. Area is meter per second. Area is just meter. So area is square meter. I'm sorry. Ayan. So tama pa. So that cubic meter divided by cubic meter, we have coulomb as a unit of Q. So tama tayo. Let's continue. So let's further simplify this. We want to relate drift velocity, concentration, charge, and area to current. Okay, so yan yung target natin. Because we already know that current is the derivative of charge, no? Or charge per time. Such that if Q doesn't change with time, we just say that I is just constant charge per time. So that our unit would be coulomb per second, also known as ampere. Okay, very good. Ayan. So let's continue. So you have Q and A. dx should be written in terms of drift velocity. Okay. So we know that speed is just distance over time. So if we know speed, distance, it's just, so Cx is just speed times time. So dx can be, you have the drift velocity times infinitesimal time. So we have v d dt. Ayan. Tama ba? Okay. So that if we divide both sides by time, I'll divide this by time. Kasi we want to determine I in terms of area, Q, and drift velocity. Yan yung target natin. So divide both sides by dt. This dq over dt now becomes the current. And then we just have here. So that's it. Current depends on the magnitude of the charge. The higher the electron concentration, the greater current, the better is the conductor. Larger cross-section area Y, more charges can enter, so that's higher current. And then we also have the drift velocity here. So if you check the units, let's check the units. Dimensional analysis. Let's check the units here. Help me. So we have coulomb for Q, and then you have 1 cubic meter for N. Area is square meter. Drift velocity is meter per second. So cubic meter. So we have coulomb per second or ampere. Very good. So our derivation is correct here. So in other words, aside from this as current, if you know the dimensions of the wire, let's say the radius or the diameter, and then you know the kind of material, you have N, or sometimes N is the unknown. No? So what I'm trying to say here is current is also affected by the following factors: the charge carriers, the concentration of electrons. This depends on the wire, of course, and the area also depends on your wire, and then the drift velocity is also predetermined by the the strength of the electric field, no? Kung gaano kalakas mong sinaksak mo doon, something like that. Okay? Ayan. I'm almost done with ano. So, to further check how much we understand, let's try answering this example. Where is that? I cannot find it. Let's, hindi ko yata na. Ayun. Okay, stop sharing. And then let's share this one. Okay. Yan. Let's try this problem. This is the last part of this video because this video has been long na yata. Okay. So the current in the wire varies with time. Okay, it's already a giveaway that charge depends on time. Varies with time. Current varies with time. With these relations, it's a quadratic equation, no? Yan. I equals 55 amperes. You have a constant there, and then this another constant, and then square of time. How many coulombs of charge? Okay, how many coulombs of charge? In other words, you're looking for Q. Pass across a section of the wire in the time interval between 0 and 8. Yan. So for letter A, we are to determine Q from 0 to 8 seconds, knowing that current varies with time according to this function. 55, I'll drop the units first, 0.65 t squared. So as time increases here, you know that the current changes exponentially because you have a quadratic equation, right? Yeah. So how do we do this? We know that current is the time derivative of charge. So therefore, if we get, so this now, I dt gives us in the small interval of q, but we want to get the entire q itself. So since meron ka ng small interval, and then we will integrate, okay? So we integrate dq from time 1 to time 2. Therefore, we also get the integral of I as a function of time dt from t1 to t2. So the integral of dq is just, of course, the total q, right? And then we substitute I here. This is 55 minus 0.65 t squared dt from 0 to 8. Okay, so this is just a simple integration on your part, right? So this becomes, therefore, 55 t minus 0.65 over 3 t cubed. And this is from 0 to 8. Ayan. So therefore, 55 times 8, minus, what is this? 0.217. So we have 0.217, 8 cubed, and then minus 0. You may opt not to write it anymore. Therefore, with a span of 8 seconds, there is a total of 329. This is a big charge already, no? Because 55 amperes is already a very huge current. Yan. 329 coulombs. Yan. So the increase is not linear, ha? It's quadratic kasi, exponential siya. Okay, so that's the total charge. If the current changes exponentially with time. And then follow-up question B, what current, so this time you're asked of the constant current. It's no longer time dependent, but it's a constant current. What constant current would transport the same charge in the same time interval? So basically, you're just asked of I if you want to produce or to transport the same charge that we solve in A. So just simple, it's just Q over T. Therefore, you have 329 coulombs per 8 seconds. So a constant current of 41.1 amperes would be able to transport 329 coulombs. So, parang similar siya in a span of 8 seconds. Okay? Ayan. So, I hope that you will try solving numerical exercises from our textbook and also try answering conceptual questions. Okay? This is enough for this video. I will make another video discussing resistivity and resistance. Okay? Stay well. Bye-bye.